Good evening. My name is Rob Krieger from the BAIS 550 course. I'd like to spend a little time this evening on a brief overview of the role of the cloud and some of the associated infrastructure. Here are some of the topics we're going to cover this evening. We're going to talk about some overall trends in big data and cloud computing, cover a brief history of data collection, going to discuss what big data is. Then we're going to move on to cloud computing and the Internet of Things. Then we're going to leave you with a few considerations to keep in mind as you move forward. So as we start to look into the trends, we can check with places like Industry Week magazine. When we look at this, we can see that most companies out there realize that there is an Internet of Things initiative necessary. They're looking to the future and realizing that they will need a defined digital strategy. But when you look down towards the bottom, SAP, the third largest independent software manufacturer, shows us that less than half of any of the companies out there have actually started this process. So to understand some of the value we get from the cloud, we first need to address big data. To get a little perspective, we'll start at the beginning. We've been collecting data as humans for as long as we've been around. As far back as 18,000 BC, prehistoric man used what were called tally sticks. In this case, it's what's called an Ishanga bone, the fibula of a baboon if you're curious. The notches in the bone are the numerical calculations, believed to keep track of trading activities and supplies, allowing them to make predictions as to how long their supplies would last. One of the first calculating devices was the abacus, around 2400 BC. The earliest repository of data we know of is the Library of Alexandria. It housed somewhere in the neighborhood of 500,000 scrolls and documented pretty much everything we knew about everything at the time. Around 1880, we saw an early example of devices doing the calculations for us, with the Hollerith tabulating machine. At that time, by hand, census workers would take around 8 years to crunch the census data. With the Hollerith machine, that was reduced to 3 months. As computers started making their way into every house and business, data and data storage really starts to take off. By 96, data storage becomes more cost-effective than paper. 97, it's estimated that 12,000 petabytes, or 120 billion gigabytes, of data is being stored. By 2000, the yearly production of stored data was the equivalent of 250 megabytes for every human on Earth. And in 2008, it was estimated that the world was processing 9.5 zettabytes of data, 12 gigabytes per person every day. Now that is a lot of data. Big data itself refers to the large amount of multi-source, heterogeneous, and real-time data, which is generated during research and development, manufacture, operation, and maintenance. Here's a couple of the things big data will help us with. So for one example of the companies out there that are utilizing big data, we'll look at Boeing. It is calculated that for every flight that the Boeing 787 Dreamliner takes, the plane records at least 500 gigabytes of data. They have sensors all over the plane. They monitor engine speed and vibration, pitch, roll, and yaw recorded by time, aileron angle, and the forces on the piano hinges. They even check the wind speed and the cabin environmental conditions. This is all done in real time. It allows us to analyze problems while the plane is still in flight. With that, you could either A, have a different plane located and prepped to offload the passengers and continue the route, or B, you could collect the materials and tools needed to have them repaired and have that waiting at the gate. Big data allows you to save time and money. So another way to look at big data is to describe it. Commonly it is described with our 5 V's. There's volume. There's a large volume of often complex data being received. The velocity. Data streams move in at a high rate of speed which must be dealt with in a timely manner. Variety. Data is received in several formats, structured such as numeric data in traditional databases, and unstructured data such as text, email, video, audio, sensor recordings. Variability. The meaning of the data itself changes over time. Variability refers to the specific context used to categorize it, such as data that is labeled from engine versus from motor. If the system knows that it is coming from a machine tool, it knows that it can't be an engine and must be a motor, and so it has to be categorized as such. And value. Does the data have value? Is it new data? Does the data stream contain copies of data already stored? The value of the data is dependent on what you plan to do with it. So for the companies out there utilizing big data, they're finding big benefits. According to Ingram Micro Advisors, the top 10 benefits of big data are things such as product quality, supply planning, manufacturing process defect tracking, output forecasting, supplier components and part defect tracking, supplier performance data to help them renegotiate contracts, the increase in energy efficiency, testing and simulation of a new manufacturing process, and the support of mass customization in manufacturing. So how do we gather all this data so we can put it to use? We connect our equipment through cyber physical systems. Fiber physical system, also known as a smart system. For an example shown here, we can install a vibration sensor onto this motor. This sensor, along with several others like it, will pick up vibration, translate it into a digital format, and translate it to our database over the plant Wi-Fi network. Then it will be organized with similar data and stored for future use. Can we get an immediate benefit from this output? Yes, we can. Here's an example of that vibration signal. Let's say we see several weeks of uniform vibration, then all of a sudden something changes. Monitoring this type of output will allow us to see potential problems before we may be able to hear or feel them at the machine. This allows for a data-driven decision-making process. There are also many software packages out there that we can have daily reports emailed to us, or we can set up a rule within the software itself to email us an alert once the frequency goes outside of a certain range. This prevents us from having to wait until there's a failure on the plant floor for a problem to be addressed. After collecting our monitored data, we need to be able to access this, have it displayed for us in real time, in this case through a digital dashboard. There's software available for all kinds of applications, including mobile devices. What we see here are a couple possible dashboard layouts that can be created so that we can pull out our phone or tablet anytime from anywhere and see what our current values are, real time, not the next morning or at the end of the week. This type of monitoring is a local monitoring. So all these personal devices and sensors we're talking about are part of what is called the Internet of Things. Internet of Things is a term you've probably heard often. In our everyday lives, it's things such as TVs and computers, cell phones, even your refrigerator possibly. We can bring that term to work now as well. The industrial Internet of Things includes those same computers, monitors, and cell phones, but it also includes a fleet of sensors and machine controllers and cameras. Any embedded device that reports data via the Internet is part of the industrial Internet of Things. According to the National Science Foundation, there will be about 50 billion devices and nearly 1 trillion sensors as part of the Internet of Things by the year 2020. There are many advantages to the Internet. When you hear the term the cloud, we're talking about the Internet. All the devices from all over the world connected to the Internet form a cloud of data. This is where the term cloud computing gets introduced. Cloud computing is a general term for the delivery of hosted services over the Internet. There are 3 categories within this umbrella of cloud computing. Infrastructure as a service includes the data center within your building, network firewalls and security, and third-party servers and storage. Platform as a service. It is a cloud-based operating system for your various devices and software. It is where third-party providers host hardware within their infrastructure instead of yours to keep you from having to purchase it. Software as a service is where those same third parties host the applications from their infrastructure again and make it available to you. Machine programming software, analysis, and design software. Technology is expensive. This is one of the greatest advantages of cloud computing. It allows everyone to have access to the same high-end programs, platforms, and software no longer have to be purchased and maintained by you. Third-party provider will be able to utilize the economy of scale and lease these services to you at a lower cost. Some of the benefits of cloud computing are that they are self-service provisioning. You can get computer resources for almost any workload on demand. There is an element of elasticity or scalability. You can use more or you can use less as needed. And it's pay per use. The amount you pay changes both with the volume of data and how often you access it. So what do some of these services look like? Let's compare some data storage options. Our design data, our programming data, and maybe in the future even our sensor and monitoring data will require a lot of space. Yeah, you can use your own computer for this, but one of the drawbacks will be that that amount of data, that large volume, will overload any standard workstation in pretty short time. The amount of data will require a separate server. The advantage to a server is that analysis projects or large queries can be submitted, and the local machine will remain free to continue working. An in-house server, which is a CapEx item, can get really expensive though. Many don't wish to spend that kind of money. How much does it cost? The thing about servers is that they're sold somewhat similar to a car. If you do a Google search for a similar server, the price you will see is for the box and the chips. In most cases, you will want to upgrade these devices since the ones that come with it are base models. For redundancy, most IT departments also install 2 hard drives, and if one goes down, your whole plant doesn't go down, you just switch over to the other. When the 2 drives are included, you need a controller as well. You upgrade your processor for speed for all that data. Then there are service plans. Then there are boxes built and installed. Then you take a look at utilities, the power, and the security requirements. The suggested lifespan for this is just 3 years. Just like any digital device, it'll start to slow down over time through a natural decay or data fouling. Oh, and the other thing, servers are generally set up in pairs, one for operating and a second for backup. Now we can double this price tag every 3 years. If we look at Amazon instead, we can see that the installation cost doesn't really exist. Their material is already up and running. The cost for 3 years when compared to the same server available that we were looking at in-house is a lot cheaper. And the memory storage charge is only utilized when you're actually transferring data. So as you can see here, it's well under half the cost to look into Amazon. Software is also a capital expense, and it's a pretty steep one. Leaves many small companies using outdated software and out-of-date versions. Software as a service in the cloud gives you access to the latest software. This can make it easier to transfer files without having to receive a translated version, which loses many of the original features in the process. As a subscriber instead of an owner, you won't have the responsibility for maintenance or updates. Here are a few of the more popular manufacturing providers who have virtualized their existing programs, or are in the process of creating newly coded versions specifically for the cloud or for mobile devices. When we look into cloud-based manufacturing services, we realize that we can do almost an entire process on its own. One possibility is to design and source within the cloud. With limited capital, you can use the cloud to design the parts in a limited run and then source them online as well. You access the software as a service to utilize the 3D CAD packages and all the testing software, and then when you're finished with that, you can submit it online and have it automatically bid by multiple shops at the same time instead of manually sending out RFQs to each of them. Here's an example based off of a small drone. If a customer comes to you for a single source bid, or if you have designed a couple drone parts yourself, but one of the components is outside of the capacity of your machines, you go to the cloud and design this part. If you buy the material and the software in-house, you can see that it would cost you about $41,000 to buy the software, and then if you had the machines, your machining time and overhead runs to about $1,800. $41,000 by the time that first part comes off the line. If we go to the cloud and we access software as a service, we don't have to buy any of that, and we can lease it, in this case $572. Then we have hardware as a service. We're renting somebody else's machine, either their printer or their machining center. So the total when this first part comes off the line is $817. If we take this bid back to our customer, we find that any quantity under 600, which is our break-even point, is the point at which we make money. So with all these possibilities I've thrown at you, you may be wondering where we're going in the future. One way is predictive manufacturing and maintenance. There are a lot of different definitions of AI. The definition we are concerned with here is simply a technology that enables a machine to perform a task similar to humans. AI learns from experience just like we do, only its pool of data will consist of billions of experiences instead of the limited number contained within one human mind. If we think back to the motor we spoke about earlier, what if we combine our motor data and the maintenance and repair logs with the data logs of 100 or 200,000 other users of that same motor? Then we throw in AI to sort and organize it all out. At that point, with that amount of data, the AI can become predictive. For example, if 20,000 motors all showed a specific frequency immediately before they suffered a seized shaft bearing, the AI can analyze all those readings prior to the event and build a predictive model. Imagine if you could receive an email that stated there is an 80% chance that the forward shaft bearing will fail between 120 to 130 hours from this date. You wouldn't have to wait for a surprise failure to shut you down at the most inconvenient time. You could use the information provided by the AI to schedule preventative replacement. So as we start thinking of moving towards big data and cloud computing, what should we keep in mind? Here's a few ideas. Data privacy. With big data, we now generate lots of information, designs, and IP, much of which we have a right to keep private. Who do we allow to have access to this data? Data security. Is our data safe? Does the cloud service we use have high-grade encryption and firewalls? Data availability. Will we have access to our data anytime we wish? Data capture. Big data collects a lot of information from several sources: machine sensors, facility sensors, logistics statistics, material suppliers, and production floor monitoring. Will these systems capture the right stuff? Data sharing. The information collected and analyzed by big data can be utilized to improve processes beyond the production floor. All aspects of a company, from sales to engineering, will be able to retrieve the most recent version with the most up-to-date software to visualize and improve their procedures and processes. So to wrap it all up, here are a few conclusions to keep in mind when considering the cloud. Big data is here. The ability to automatically collect significantly large amounts of data creates new opportunities to improve our processes. The cloud allows us to connect to services traditionally not available to the little guy. Cloud computing provides us the opportunity to utilize the latest and greatest at a reduced cost. And cloud-based design and manufacturing allows us to provide additional services to our customers or for ourselves. Again, my name is Rob Krieger. Thank you for spending time with me this evening on Big Data and Cloud Computing.